I've got the equation y equals, don't leave it in your TI looking just like that. Cool? Leave it in your TI looking just like that. But I'm going to round down the decimals just for simplicity for writing it down. Y equals 2.21 x squared minus, looks like 0.84 x, looks like plus 0.62. Now, what does that mean? Well, the x and the y mean something. Does anybody know what x and y mean in this model? What is, let's not lose that. What is x? Do you remember what you put in L1?
Distance. Zero.
Well, x is 0 at the beginning, you're right. What did you put in L1?
Seconds. X is the run.
Well, technically speaking, well, let's use context. What did you put in L1 of your TI? The seconds, the time, yes? So x stands for the amount of time in seconds my trip is. And y is my distance in feet. Y is my distance in feet. Now I want to make sure you guys have this. This is why you put what you put in your TI. You put L1, you put 0, 3.4, 4 point something, 5 point something, 8, I don't know what exactly you had it. But you put the time into L1, and then you put 0, 25, 50, 75, 100 into L2. Please.
I got a different equation.
You did. Let me see. It's probably data differences. You. I think I see what's going on here. The first, yeah, you're missing. That should be 0, 25, 50, 75, 100. So you're either missing some data. Check it against Michelle's. Well, okay, let's not worry about that right now. We have 5 minutes. I can take a look at your guys' individual TIs after class. But I want to make sure you know what that model is doing for you. What that model is doing for you. And I don't want to get too far from this whole rise, run, rate of change thing. Fair so far? Good so far? Good so far, maybe. Getting there. Maybe. So here's what's kind of cool. Here's what's kind of cool. Suppose I want to know where I am at the hill after 2 seconds have passed. I want to know where I am down the hill after 2 seconds have passed. Say that again. Yes, I can go to my table, can I? I go to my table, and I can simply input 2, and it will tell me I'm about 7.8, almost 8 feet down the hill. Fair enough? Now, remember, this is a best fit line, not a perfect fit. Or, I call it a line. It's not a line, it's a curve. This is a best fit curve, not a perfect fit curve, yes? Where was I at 0 seconds?
0.627.
Well, that's what the model says, right?
Oh, yeah.
At 0 seconds, the model says I'm about 0.6 of a foot down the hill. Now, Chrissy's saying, wait a minute, at 0 seconds, where was I? At 0 seconds, I was at the top at 0 feet. I haven't gone anywhere yet. But remember, the model's a best fit model, not a perfect fit model. Is that fair? It's trying to take all those little errors that we talked about at the beginning of class and smooth them out. So the model thinks I was about 8 inches down the hill, 8 inches down the hill at 0 seconds. Can we live with that? Well, that's a loaded question, right? If we were building something like a bridge, I would say, no, we can't deal with that. Because that's how trucks will put trusses and knock bridges down and things like that. Yes. But for the sake of our argument, I think we have to live with that. And for the policeman and his hairdryer, it wouldn't be good enough either. But they also have more precise instrumentation than we do. So, I can live with it for the sake of education. That's okay with you. Thank you, Ashley. Now, what we're going to learn next time, we're going to get into next time is the difference between an average rate of change and an instantaneous rate of change. Okay, an instantaneous rate of change is what your car shows you on your speedometer. How fast are you going right now? Right now, look down, 25, 30, 45. An average rate of change is knowing how long it's going to take you to get to Boise from Bend. How long does it take? Boise to Bend. Bend to Boise. 6 hours? How do you guys know that?
I've driven it.
You've driven it? Wait a minute, miles per hour, wait a minute, miles per hour, say that again.
So then, because I'm just like, okay, if I were going at an average of 60 miles an hour.
If I were going at an average of 60 miles an hour, times 6 hours, that's 360 miles, which is roughly the distance from Boise to Bend.
I think it's like 364.
It's like 364. Hot damn! Now, here's the question. How is it possible to drive from Bend to Boise going 60 the entire time? Well, it's possible. Is it probable? Right, you're not going to make it through Burns going 60. Somebody's going to get hurt, or arrested, or both. But,
You might start going 25, but once you get on the highway, you might be a speed demon and over 80.
and when you hit Idaho, the speed limit cracks up. I believe it's 80 now? In sections, it's 80 miles. I know, it's insane. I get nervous driving that fast. Seriously. It is.
Drive on the Autobahn.
So, let's talk about that on Wednesday, yes? Let's talk about that. How we can somehow rectify this 360 and this 80 and this 25 and all this other stuff.